Hello and welcome to Chapter 3, Section 1. Today we're going to start looking at matter and substances. For today we're going to primarily be looking at what makes up matter. We'll look at why atoms form bonds and what are some of the important interactions between substances in the Part 2 video. So to begin with, we have to understand kind of what the most basic level is. Okay, so to begin with, every living and non-living thing is made up of matter. Now, matter is going to be defined as anything that has a mass and takes up space. And all this matter that is out there is made up of very small particles that we call atoms. Now, atoms are the smallest unit of matter, and it cannot be broken down by any chemical means. So what this means is you can't break an atom down and make it into a smaller amount of matter. It's the most basic unit of matter that is out there. So to start looking at an atom is going to have what we call a positively charged core. Okay, so the center of it is essentially going to be positively charged, and then all around the outside region is going to be the negative charges. So it kind of surrounds that positively charged core with a negatively charged region, and we have a picture that'll be coming up here in just a second. Now, the nucleus of the atom is made up of positively charged protons and what we call uncharged neutrons. So again, if I look at an atom, in the very center, you're going to see all these positively charged protons, okay? So I think about a proton starts with a P, and positive starts with a P. So a proton has a positive charge, and these are going to be in the center, and they're going to be surrounded by these neutrons, which are uncharged, or they have no charge. They're neutral. Then around that positively charged nucleus, okay, where the protons and the neutrons are, we have negatively charged electrons. The electrons have a very, very small mass, okay, and they move around this nucleus in a large region called the electron cloud. So if you look at this picture here, you can see in the center here of our nucleus, we have these little red spheres and these white spheres, okay? These are the positive and negatively charged, the positively charged protons, okay? And we'll just say that those are the red ones for now, okay? The white ones are going to be the neutral charged neutrons. And then this blue region around the outside is where those electrons are floating, because these are constantly moving around. And those electrons, which are negatively charged, are kind of moving like so fast and always moving that they create like kind of the appearance of a cloud. Now from the atom, what we can do is we can start grouping atoms that have the same number of protons together, and we create what we call an element. So an element is a substance that is made up of atoms that have the same number of protons. So if you look at a periodic table, which is what I have down here, okay, when I look at that element like helium right here, helium has atoms that have 2 protons, and I know that because of this little number up in the upper left corner. If I come over here to like element number 11, sodium is going to have 11 protons. Okay, every sodium atom is going to have 11 protons because that's what makes sodium sodium. If I come down here to element 26, which is iron is going to have 26 protons, okay, and this is what we call the atomic number. Okay, the atomic number tells me how many protons that element has, and it's that number of protons that makes each element unique. Okay, so carbon will have 6 protons. You can look over here. Chlorine is going to have 17 protons. That's what makes each element, that element is the number of protons. Okay, so just to reiterate, if we look at the element carbon, okay, carbon has 6 protons, and again, I know this because of the atomic number that is right here. This equals the number of protons. Okay, and it can equal the number of electrons if that atom is neutrally charged. Now, sometimes we have atoms of elements that have a different number of neutrons. Now, remember, a neutron has neither a positive or a negative charge. But if the neutrons do not equal the number of protons, then we call these elements isotopes. Okay, so we're going to look at an element box from the periodic table, and we're going to look at a few things on that, and then we're going to talk more about isotopes. So if you look at the periodic table, you will normally notice, as you saw a few slides ago, that it's full of a bunch of little boxes. And in each box, regardless of the periodic table that you look at, they almost always have the same basic information. Somewhere on there is going to be the chemical name, okay? Somewhere is going to be the atomic number, okay, which in the periodic table I showed you a minute ago, that was in the upper left corner. All you have to do is look for a key. Okay, we have an element symbol, and then we have what we call the average atomic mass. Now, the average atomic mass is going to be similar to the atomic number, but it's not going to be the exact, okay? And that's because the average atomic mass, which we'll go more into in chemistry, but this is essentially like an average of all the isotopes that are available in nature. So, just to talk a little bit more about an isotope, remember that an isotope is an atom that has the same number of protons, but different numbers of neutrons. Okay, so atoms that have more neutrons then are going to have a higher mass. Okay, it doesn't change the chemical behavior of that atom, but the mass is going to be slightly higher. Okay, now with isotopes, a lot of times we have different notations, okay, called isotope notations. And typically, an isotope is identified by its mass number. Now, the mass number is different than the atomic number, okay? But your mass number is essentially the sum of the atomic number, okay, which is your number of protons, and your neutrons. So we can say that mass number is equal to protons plus the neutrons. So sometimes an isotope is going to be written kind of like in this format here, okay, where the mass number is going to be the number on the top, and again, that's your number of protons plus your neutrons, and then you have your atomic number, because the atomic number tells us the number of protons, which is going to tell us which element it is. So an example of this is going to look something like this right here. This element here is copper. That's what the element Cu is. Copper also has 29 protons, so I can say that protons are equal to 29. My mass number is 63, so if you remember, mass number equals protons plus neutrons. So from this alone, I know that my mass number is 63. That's going to equal my number of protons, which we said was right here, or 29, plus n. So I can solve my number of neutrons by subtracting 29 from both sides and saying that my number of my number of neutrons is equal to 63 minus 29, or I have 34 neutrons. So again, this is an isotope because my number of neutrons is different from my number of protons. Now, another notation that you'll see is this notation right here. This is our element symbol. So again, I can see that it's copper, and 63 is my mass number. So I would have to go to a periodic table to find out what my number of protons is, or to see that that's really 29, and then I could find my number of neutrons once I knew that. Okay, so if we look at example 1, it says, based on the given table, we want to determine the number of protons, electrons, and neutrons for each isotope. Now, in Teams, under Files, there is a periodic table for you. So that will help you when you're doing your homework like this over the next couple of days. So, off that periodic table that I have posted in Teams, I've zoomed in on the element chlorine. Okay, again, this is another notation for isotopes. Chlorine-35, the -35 is my mass number. So you will have homework that looks similar to this. But if I look at this table, my chlorine-35 element, I can go in and start filling things in. My mass number is this right here. So I can fill that in. My atomic number, if I go and I look at a periodic table, my atomic number is this number here in the upper left corner. So that will be 17. Now remember, your atomic number is really the same as your number of protons. So I know that my number of protons is 17 as well. And because this is not a charged particle, my electrons are also going to be the same as my number of protons. Now the only thing I'm going to have to calculate is my number of neutrons. So to find the number of neutrons, remember, neutrons are going to equal your mass number minus your protons. Okay, so for chlorine 35, my mass number was 35. And from that, I'm going to subtract 17, and I'm going to end up with 18. So I have 18 neutrons. Now I can go ahead and do the same thing for the next one, which is chlorine 37. Again, the 37 is my mass number, so I'm going to start there. Then when I go my atomic number, because I'm still dealing with chlorine, my atomic number is still 17. The atomic number is the same as my number of protons, which is also the same as my electrons. Now, to find my number of neutrons, this is my mass number minus my protons, or I have 17. Mass number is 37 minus 17, which gives me 20. Okay, we'll go through a few more of these in class together. If you have any questions, please let me know. Otherwise, have a great day.